Hello friends, today we study fire and explosions. So these are the nothing but the two types of accident that happens in industry. So we will study that. So for our as a safety engineer, we should avoid the fires and explosion type of accident to happen in industry. So we should be familiar with the 3 points for avoiding that. So that is the first point is, so we have to study the fire and explosion properties of the material. Second thing, we have to study the nature of the fire and explosion process. And the third one is very important, is to procedures to reduce the fire and explosion hazards. So this is how we have to study. Now next thing we in the very important in the studying fire and explosion is the fire triangle. So here it is nothing but a triangle which has a three side. That is, the first side is the fuel, second side is the oxidizer, third side is the ignition source. So these are the three essential element for combustion. Or so whatever fire occurs, so it may require three essential elements. So first one is fuel, second is oxidizer, third one is the ignition source. Now by going through the diagram, we can see that if the three sides are in contact with each other, so there will be a fire may occur. So the three sides are oxygen, fuel, ignition source. If the three sides are in contact with each other, there will be a fire may occur. Now if one of the side is not attached, so there will be no fire may occur. So that is only the significance of the fire triangle. So all the safety engineers should know all these things. So that is the fire triangle. Now we can see here from the diagram itself, we can say that the fire will occur or fire will not occur if, first thing, if the fuel is not present in or not present in a sufficient quantity. Second condition that for fire will not occur is the oxidizer is not present or in the not present in the sufficient quantity. And the third one is that is to there will be no ignition source, or ignition source is available but it is not energetic enough to initiate the fire. So these three things are important for studying the fire triangle. So first thing, we should know that the three sides are there. If the three sides are in contact, there will be fire will occur, combustion will take place. Then if it how it will not occur, when the three sides are not in contact with each other. That is only the significance of the fire triangle. Now we will see the different examples of the fuel that may be present in industry. So here liquid will be of in the fuels in the form of liquid, or maybe gasoline, acetone, ether and pentane. Now in solid form, fuel may present is plastic, wood dust, fires, metal particles. And in gaseous form, the fuels are acetylene, propane, carbon monoxide and hydrogen. Now we will see the example of oxidizers that may be present in industry. Are in gaseous form, they are oxygen, fluorine, chlorine. So these are the oxidizers which may enhance the fire combustion. So these are the gaseous form example of gases that may present in industry. Then in liquid form, they are hydrogen peroxide, nitrogen, nitric acid, perchloric acid. So then in the solid form, it may be metal peroxide and ammonium nitrate. These are nothing but oxidizer that will enhance the fire. Now you will see the examples of the ignition source that are present in the industry. So it may be spark, flames, static electricity and heat. So these are all the three sides of the fire triangle, or examples of the three side of a fire triangle. So if these are present, there will be a chance that fire will take place. Now, to avoid the fire and explosion type of accidents in industry, we should be, first thing, in the first slide itself we have seen, for avoiding that this type of explosion, we should know the fire and explosion properties of material. So how we can familiar, or how we can know the fire and explosion properties of material. Now we can see these are the basic very important definition for studying the properties of material, fire and explosion property of the material. A very first thing we have to should know what is fire. Now fire is nothing but the fire, it is nothing but the combustion. It will be also called as a combustion. Now how it is defined? It is defined as the chemical reaction in which the substance combines with the oxidant and release some energy, and that energy, part of energy is released, that is used to sustain the reaction. So that is nothing but the fire. The second important thing is the ignition. Important definition for studying the fire and explosion type of accident. So it is nothing but, so ignition, it is nothing but a small energy source is given to the that reaction mixture. So it is nothing but ignition. Now we can see here from the actual definition, ignition of flammable mixture may be caused by flammable mixture coming in contact with the source of ignition with sufficient energy or a gas reaching a temperature high enough to cause a gas to auto ignite. So this is nothing but the ignition is nothing but the small source of energy given to the material which may cause fire. Now the second point is very important. You can see AITs are nothing but the important property of a material that may we can see in the MSDS also of every chemical. So it is a auto ignition temperature. So it is nothing but a fixed temperature at above which the adequate energy is available in the environment to provide the ignition source. So it is nothing but the temperature at which the material will automatically take the energy from the environment to to catch fire. So that is nothing but the auto ignition temperature. So it may be also defined as the temperature at which the material or the chemical compound will take the energy from the environment and it will catch fire, and or the combustion will take place automatically. That is nothing but the auto ignition temperature. Now we see the next very important point for studying the property, fire and explosion property of a material is the flash point. Now what is flash point? Flash point is the nothing but, it is the lowest temperature at which it gives off, the chemical gives off enough vapors to form an ignitable mixture with the air. So it is nothing but the lowest temperature at which it gives off the energy enough vapor to form a ignitable mixture with the air. So at this point vapor will automatically burn. So at the flash point the vapor will burn briefly, and adequate vapor that is present, it will be produced to maintain the combustion. So that is a very important point for flash point. It is also given in the all the MSDS of a chemical. So flash point is also given in the MSDS. That is, MSDS is nothing but the material safety data sheet. Now what is the property of that flash point? We can see here the flash point generally increases with the increasing pressure. That is the, it will increase with the increase in pressure. Now how to calculate that? There are two methods that is available, that is open cup and a closed cup method for finding out the flash point of the chemical. Now next important thing we will study is the fire point. The fire point is nothing but the lowest temperature at which the vapor of above a liquid will continue to burn once it is ignited. Now fire point is higher than the flash point. Now what happens here? At the lowest temperature at which the vapor will above the liquid will continue to burn once it is ignited. So both of these things are very important for studying the fire and explosion properties of a material. So these are the properties which may define how fire will take place and while handling that particular material. So all these points are given in the MSDS itself or with the chemical. Now next thing very important is the flammability characteristics, flammability limit. Now what happens here? Here what happens, you can see from the definition, it's a vapor and air mixture will ignite and burn only over a well specified range of a composition. Now what is the composition here? When the liquid is there, it will release some vapors into the air, and that vapors will mix up with the air with the well specified composition, and it will make a ignitable mixture. When it is given a small ignition source, then it will catch fire. So this is a well specified range of a composition of a vapor. Now what will happen if the vapor composition is low, so that it will not catch fire, and also when the vapor composition is very high, it will not catch fire. So the two terms are very important for studying, that it is a level LFL, that is a low flammability limit, and UFL, that is the upper flammable limit. So the low flammability limit is nothing but the mixture is too lean for the combustion. So the mixture is not combustible when a composition is too rich. So when the vapors are released, it will mix up with the air. Now if the composition of that vapor is very small, so that mixture will not catch fire, and if the vapor released into the air and it is having a maximum composition, again it will not catch the fire. Now how will fire will occur? Fire will occur only within the range of that LFL and UFL. So when the composition is between LFL and the UFL, fire will occur. It is also important properties for studying the flammable fire and explosion properties of a material. Again, this term is also given in the MSDS. We can see what is it is a very important thing for studying the properties of the material. So MSDS in all the chemical, flame LFL and UFL is always given. Now we will study next type of explosion. Next type of accident, it is a explosion. Explosion is nothing but it is a rapid expansion of a gases resulting in a rapidly moving pressure wave or a shock wave. So it is nothing but it is an explosion. It is nothing but the rapid expansion of a gases. So it may create pressure wave or a shock wave. So expansion can be mechanical, or it can be result of a rapid chemical reaction. So here the damages are very high. So we have seen in the last videos, so explosion may cause most of the damages to the plant. So then there are different types of explosion. So it is a mechanical explosion, then dust explosion, various explosion types of explosions are there. Now in mechanical explosion, what happens? It is nothing but the result. It is a explosion resulting from a sudden failure of a vessel containing high pressure non-reactive gases. Now if there is a suppose there is a storage tank, and it has a liquid present in that. Now due to certain reasons, various reasons, when the vapors above that liquid is increased, so what will happen? There will be a damage to the integrity of that vessel, and due to that some leakage will occur and the gases will be released. So it is a type of mechanical explosion. Now we will see there are also one type of explosion is the deflagration type. Now it is nothing but very important thing is that an explosion in which the reaction front moves. That means whatever the pressure waves are created, it moves at a speed less than the speed of sound in the unreacted medium. Now what is that unreacted medium? Suppose at this point the explosion occurred, so this is a reactive medium, and other than that reactive medium, all the things are unreacted medium. So what will happen? Whatever the explosion will take place here, it will create a pressure waves and it will move towards the unreacted medium. So when these waves are that is created, if you determine the speed of this pressure wave, if the sound it is less than the speed of sound, that means it is a fire, that is a deflagration type. Now same as that detonation, when the speed of this pressure wave is greater than sound wave, it is called as a detonation type of explosion. So this is also a very important point for studying explosions. Now we will see next type of explosion is the very important dust explosions. Now these explosions generally results from the rapid combustion of fine solid particles. So many solid particles including iron and aluminum become flammable when it is reduced to fine powder. So generally this type of explosion may occur in the metal industries. So that is a dust type of explosion. Now next type of explosion is the boiling liquid expanding vapor explosion, that is also called as a BLEO. So it occurs if the vessel that contains liquid at a temperature above its atmospheric pressure or a boiling point ruptures. Suppose this is nothing but a vessel, storage vessel. It contains a liquid and some space is given for the vapors. Now what will happen due to some various reason, if temperature around that vessel is increased, so what will happen, the vapor composition will increase and the pressure around this temperature around this vapor will be increased. So what will happen, the atmospheric pressure, so what will happen, temperature above its atmospheric pressure will be increased. So composition, vapor composition increased here. Due to the increase in the composition, so this integrity of that vessel will be hammered and there will be a rupture and the explosion will take place. So that is a type of boiling liquid expanding vapor explosions. It is also very important type. This may happen generally in the industries. So that is the types of explosion. Now you see next important type of explosion is the confined and unconfined explosion. Now from the name itself we can see that what is confined, it is confined to the particular area or the particular section of the plant itself. So it is nothing but a confined explosion is occurring within a vessel or a building. These are most common and usually result in the injury to the building inhabitants and extensive damages. Now what will happen, if there is a plant and only one section there is an explosion takes place and it is confined to that area also only, so that is called as a confined explosion. Now what is unconfined? Now unconfined explosion occur in the open. This type of explosion is usually the result of flammable gas spill, and this gas disperses mixing with the air until it comes in contact with the ignition source. And unconfined explosions are rarer than the confined explosions, because the explosive material is frequently diluted with the LFL by the wind's dispersion. Now what happens here, why it is rare, because you can see here what will happen. Suppose this is the reactor, and in this reactor what will happen, due to some reasons, some mechanical failure, some crack will happen here in the reactor. Now what will happen, whatever the liquid present in that, it may convert into vapors and that vapor will come out from the reactor. Now it may form a cloud of that vapors here. So what will happen, what will happen due to some dispersion, what will happen, these vapors will again it will make a cloud and it will disperse throughout the plant. So what will happen, due to that the cloud will be dispersed throughout the plant and there are various sections in the plant. So for that small energy source, that is ignition sources are available, and if that ignition source is given to that cloud, that may catch fire and explosion will take place. Now this is not common, because what will happen, we have seen why it is not common or rare, because LFL we have seen and UFL. Now the explosion will take place only within this region. Again the composition is within this LFL and UFL. Now generally what will happen in the plant, the air will be present always and it will mix up with that air, that vapor. What will happen, it will dilute that vapor continuously. So that's why it is a rare thing to happen. Now we will see next important definition is the shock waves. So it is nothing but a shock wave. Now what happens here, a pressure wave moving through a gas. A shock wave is a abrupt pressure wave moving through a gas. A shock wave in open air is followed by the strong wind. The combined shock wave and wind is called as a blast wave. The pressure increase in the shock wave is so rapid that the process is mostly adiabatic. So these are also a shock waves created when the explosion takes place. So in this last 19 minutes, what we have studied is the fire and the explosion type of accidents and how to avoid that. For avoiding that, we should know the fire and explosion properties of the chemical. Now, how we can find out that properties? So, we have studied various definitions that are important for studying the fire and explosion properties of the material. Now, after studying that, we will apply some preventive measures so that there will be no fire may occur. Now, for fire, we should know also we have studied an important point is the fire triangle. So these are all the study all the topics we have covered in this video. So thank you friends.